that chair may be more like, interrogation chair when I turn on the overhead, so I apologize if you, but. What's your name again? Sorry. Chris. If it gets too dark, let me know for taking notes, okay? I'm hoping that there's enough light in the room. But is that too dark for you to take notes? Are you sure? Okay, that's. that official JMU stuff there? What sport is that?
Soccer.
Soccer, ooh, that's nice. I've had a couple soccer players and, trying to think who was, I don't think you would know Thomas. Thomas graduated probably.
Shoulders?
Yeah.
I've heard about him,
Oh, you've heard about him,
Yeah.
okay, yeah, he was one of my advisees,
Oh, okay.
math major, I had him as a student, he was really good, he was really good. Who did I have? I had Nick maybe last 2 summers ago. But yeah, I mean, they went to the final 8. I mean, we had a team like go to like the Elite 8 in soccer. And we're not talking like CAA, I mean, we're talking like in NCAA Division I. And they were talking about like other sports. I'm like, do you not understand? We got a soccer team that's competing as the Elite 8. Where's the press for that? Where's the press for that? I'm still angry about that. So you guys fall sport?
Yeah, we're close.
So are you gonna play in the spring?
Yeah, that's the plan.
Okay,
Hopefully starting like mid-February.
okay. Yeah, that would be awesome. I mean, I think those outside sports are pretty good.
Yeah.
As far as like not getting virus. I do expect a spike, guys. I expect a spike this week, and I'll expect a spike probably next week, but then hopefully after 2 or 3 weeks, it'll start tapering back down, and then we'll get to ride out from being in class the rest of the semester. You guys all healthy? You guys all healthy? How about you in the grid? Are you healthy? Are you healthy? Are you healthy? Okay, let's keep it that way. Okay, if you can turn on your cameras, turn on your cameras. Guys, if you can, just stand up, stand up. Don't breathe too much, but let's stretch. Oh, let's sit back down, Okay, it's gonna be mini moons, until you get those quests back. Mini moons, my little Indian Braves, okay? Until we get our quests back. I've got too much to do, this week and other weeks. I'm on a project for the Department of Defense that I've got to meet with some people from Northrop Grumman. So that's taking this week. Also, there won't be any office hours today or tomorrow. I've got MRI that I've got to get something taken looked at. And fortunately, RMH has a new machine, a deep scan MRI that they had to put in this fall, so I don't even have to go to UVA. So it's pretty awesome. There'll be a web assign due on Friday. It's the way I keep you doing your homework. I know if I give you a quest, you'll do your homework. And I also know if I give you a web assign, you'll do your homework. If I don't have any web, you're probably not going to do your homework. There's going to be something else that's going to take priority. You should be working in the homework in that announcement on Canvas. You should be working on the homework related to section 3.1 and 3.2. Okay, so to get your brains going, I've got some questions on the board. I've got 3 of our most important flashcards. If I'm picking out the 7, out of the 7 that we have, if I have the ones that I really want to have down, it's my power rule, my product rule, my quotient rule. So don't do anything yet. I also have some rules of exponents that are going to be important today. I have some rules of exponents. If you have like x to the 3rd times x to the 5th, you don't really want to multiply this out as x times 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 x. You don't want to do that. Or if you have x times x times x divided by x times x times x times x, you don't want to be doing all that stuff. What are the rules of exponents? And then what are some of the things that we have relating negative exponents? We have negative exponents. Rules of negative exponents. And then the general rules. Here's what numbers in there. So I want you to answer those questions. So let's get your brains going. Well, let's try to answer like these 10 questions, 10, 11 questions. Try to remember all these rules. Try to remember what you have.
Could you read them out?
Yes, I will. This is the derivative of x to the k. This is the derivative of f of x times g of x. This is the derivative of f of x divided by g of x. This is what we derived last time. This is x to the third times x to the fifth, x to the third times x to the fifth, x to the third divided by x to the fifth, x to the fifth divided by x to the third, x to the fifth raised to the third. Can you guys hear me okay through the mask? Can you hear me?
Yeah.
X to the negative 3 is the same thing as what? X to the negative 3 is 1 over x to the negative 5 is the same thing as what? 1 over x to the 7th is x raised to what exponent? And then these basic rules, x to the m times x to the n, the more general rules, x to the m over x to the n, x to the m raised to the n, and then 1 over x to the m. So I want you to try to answer those. I'll try to avoid looking too much, getting too close, even though it kills me because I really do like wandering around my classroom. So try to answer these. Like 14 questions. Try to answer these 14 questions. And don't use your notes. Don't use your notes. Just what do you have in your gray matter? What do you got in your gray matter for it? All right, you're going to breakout rooms. You're going to breakout rooms to share what you have, to share what you have. Okay, you guys are going to breakout rooms of 2. You're going to breakout rooms of 2. Just do not get together, but talk to each other about what you have. Or breakout rooms of 3, whatever you have. Talk to one other human being or 2 other human beings. Just talk about what you have for each one of those.
The first one is just
Not too
adding
close,
the
not too
exponents
close, but
together.
enough. We're not gonna start it out great. We're not gonna start it
Second
out
one,
great.
division, you subtract the exponents. And then that one, whatever the fourth one, you're multiplying the exponents. Basically, it's the same thing for everything else. Yeah, pretty simple.
And then is the quotient
What year are you?
So yeah, when you think about that, if you
No,
break
I'm a
it
junior.
into like here,
Yeah.
if you think about it as like this.
This will
if
be
you
my
explain
last
this
math
to your
class I
sister,
ever
this
have
would
to
be
take.
X times X 3 times,
And then with the exponent.
and this would mean X times X
True.
5 times.
Yeah.
So what would you do?
And then.
If I think about this as being like
Would you get the?
X times X times X, and this is being X times X times X, and that is X, how many X's are you gonna
The
have?
exponent is supposed
8,
to-
so that kind of leads you.
I don't think.
I think
So-
it's one over X to the third, X to the fifth, or one over X seven. I have no clue.
How are you doing, Laney?
Pretty good.
Oh, okay.
I thought it would be X and plus N.
Okay, guys, I hate to stop us, but for sake of time, we need to get through these. A lot of this is pre-calc, but for some of you guys, you haven't had math in a while. So for others who are just coming from high school, this is all pretty much something that you've already owned. But for some who haven't had math, and like you took that quest. I mean, I knew it was going to be a challenge because you haven't had a paper test in your hands all year, and so that's a new thing. And then also, some of you, this is really your first real math test you've had in a while. So it's going to take a little while to get back in shape. I'm hoping you own these. I'm hoping right here, I've taught you well enough that you guys could tell me, what is the derivative of x to the k? Yeah, k times x to the k minus 1. We use product rule to justify that. Now, what's the derivative of f of x times g of x? Plus f of x. I'll get out of your way, guys. And what's your name here?
Zach.
Zach. Very good, Zach. And
Che.
Che. So yeah, exactly. It's the derivative of the first times the second plus the first times the derivative of the second. How many people have that? How many people have that rule down? If you can remember that one, you've got this one. If you can remember this one, you've got that one. It's exactly product rule, but the plus turns into a minus, and then you just got to remember that you divide by the denominator squared. There's no derivatives down here. You divide by the denominator squared, and then you just write product rule down, f prime of x, g of x, but the connection sign's a minus. How many people had those three right? That is the most important. These are the most important ones to have down right now. Now let's go back to high school. Let's say we got x to the third times x to the fifth. And you forget what it is. You forget, do you add or do you multiply? If you just remember how to teach this to your sister, when you say x to the third, how would you explain that to a little sister? X to the third, what does that mean? Yeah, x times x times x. So if I think about this, this x to the third would mean x times x times x. X to the fifth means, well, Dr. Warren, x times x times x times x times x. And how many x's you got? 8. And so that kind of leads you, yes, you would add these. So when you multiply bases that are the same, you add the exponents. Now what if you have x to the third over x to the fifth? Well, you don't remember. We'll do the same thing. X to the third means x times x times x times x. X to the fifth means x times x times x. But now, this is multiplication. These guys kill each other, and you're left with a 1 over x squared. So in this case, who's ever bigger, you subtract. x to the 5 minus 3, which is 1 over x squared. Now if I flip it, then I'm going to have more x's on the top than on the, if I flip it, then I'm going to have more x's on the top than on the bottom. So in this case, it's going to be x to the 5 minus 3 or x squared. X to the 5 minus 3 or x squared. This one, please don't make me write down all these x's. Please don't make it. This would mean x to the 5th times x to the 5th times x to the 5th. That's what that would mean. X to the 5th cubed. But then how many x's do I have here? How many x's do I have there? 5. How many here? And how many there? So how many would I have altogether? How many would I have altogether? 15. And so when they're like this, you multiply. X to the negative third is defined to be, x to the negative third is defined to be 1 over x to the third. 1 over x to the third. And let me explain how you can kind of explain this to a little brother or sister. Because this one's kind of the hardest one for them to get a sense. You're all going to be teachers one day. You're all going to be teachers. You know, like Dr. Warren, I'm not going to be a teacher. The last thing I ever want to do is be a teacher. Okay, you're going to have children one day. You're going to be a teacher. Dr. Warren, I'm not going to have a child. I said the same thing. I said the exact same thing. I got 5 daughters. 5 daughters. I'm not going to have a child. I wouldn't be a good parent. Well, that was probably true. Okay, but I still ended up with children. So you're trying to explain negative exponents to your little brother or sister or child. Now watch. If I take 2 to the 5th, that means 2 times 2 times 2 times 2 times 2. Okay? And let's suppose I divide by 2. I divide by 2. Well, this would be like 32. 2 times, trust me. 2 times 2 times 2 times 2 is 32. Let's divide this by 2, and what number do you get? 32 divided by 2 is 16. Let's take 2 to the 5th over 2 to the 1. Well, that's 2 to the, you subtract and you get 2 to the 4th. Let's do the same move again. I'd have 2 to the 3rd, divide by 2. Divide by 2, you get 8. 2 squared, divide by 2, you get 4. 2 to the 1st, divide by 2, you get 2. Now this is where it starts getting interesting. Go down 1 again. 2 to the 0 is 1. We divide by 2 again. Now this is where they start going negative. Go down 1 again, negative 1. Divide 1 by 2, you get 1 half. Now go down 1 again, 2 to the negative 2. What's 1 half divided by 2? 1/4. Now this is where it's fun. But 4 is 2 squared. So this is like 1 over 2 squared. Last time, last one. Go down 1 again, 2 to the negative 3 is like 1/4 divided by 2, which would be 1/8. But we know 8's the same thing as 2 to the 3rd. And do you see how you can lead kids to pretty naturally to how negative exponents, these rules work? Okay, so x to the 7th would be the same thing as x raised to the, x to the 7th would be the same thing as x raised to the negative 7, x raised to the negative 7. However, 1 over x to the negative 5 would be the same thing as x to the positive 5. And these are the main four general rules. X, just using these as motivation, x to the m times x to the n would be
X to the n plus n.
very good. X to the m over x to the n would be x to the m minus n. X to the m raised to the n. x to the m raised to the n would be x to the m times n, and then 1 over x to the m is the same thing as x to the negative m. Now guys, are these refreshed? I mean, do you guys remember learning these in high school? Was it worth going through them? Was it worth going through them again? Was it worth going through them? Okay. So, what if we have a negative exponent? Like, for example, x to the negative 8. And I want to take the derivative of this. This is my question. What is the derivative? What is the derivative of x to the negative 8? We're like, Dr. Warren, let's not have it be negative. Michael, okay, just stop. Meaning, like, for example, if it was x to the 10th, how many people own that? How many people have that now? What's the derivative of x to the 10th? What's the derivative of x to the 10th? 10x to the 9th. We own that. What if it's negative 8? Well, I'm going to take you on a long journey, and then I'm going to show you a shortcut. What did I just say? What were the words that just came out of my mouth? So stand up since you're going to go on a long journey. Okay, pack your attention span. You're going to need that. Drink some genius. You're going to need that. Okay, dance. I like the dancing there, Lorelei. I like the dancing. Yeah, that's awesome. Okay, guys, I like the boxing. Yeah, boxing. Hit Dr. Warren. Punch Dr. Warren. Julie, you're not hitting me, man. Julie, oh gosh, I just almost broke the camera right there. Okay, let's sit back down before I destroy the room. Okay, my goal is to find, I'll know the adventure is over when I find the derivative of f, where f is x to the negative 8. Now you guys are going to help me out. But algebraically, x to the negative 8 is the same thing as, x to the negative 8 is the same thing as 1 over x to the 8. So if I can find the derivative of this function, will I have the derivative of that function? If I find the derivative of this function, will I have the derivative of that function? But look, guys, this is a quotient. This is a quotient. Do we have a quotient rule? Do we have a quotient rule? So let's use that quotient rule. To go after that. Now you guys know quotient rule. Go after it. Try to take the derivative using quotient rule of 1 over x to the 8. Use your quotient rule to take the derivative of 1 over x to the 8.
Dr. Warren, I'm confused.
Was that Julia?
Yeah.
Julia, so just think of this as your function f, and this is your function g. And then just use that rule right there.
So wait, the F, wait, which one's G?
The g is the x to the 8, and the 1 is the f if you're going to use this rule. Think of this as being the 1, Julia, and this as being the x to the 8. And then take the derivatives and divide by g of x squared. Does that make sense? Is it making sense to you guys in here too? Kind of? Okay, go to grid view. Hold up what you have. And you guys hold up what you have in here. Hold up what you have. What do you got? What do you guys have? Hold up what you guys are not holding up stuff. Okay. So you guys help me out. It would be the derivative of 1 times x to the 8 What's the connection sign in the rule? What's the connect? Minus 1 times the derivative of x to the 8, all divided by
X to the 8 squared.
x to the 8 squared. Did anybody get there? Did anybody get to that point? Was there anybody who got at least that far? Okay, so now you're gonna help me. What's the derivative of a constant? It's one of our flashcards. What's the derivative of a constant? 0. So this first derivative is 0. Minus 1. What's the derivative of x to the 8? Do you know that? Do you know the derivative of x to the 8?
8x to the 7.
8x to the 7th. Okay, use our newly remembered rules of exponents. How do you deal with exponents when they're like this, guys? How do you deal with exponents when they're like this? Multiply. So this would be the same thing as x to the 16. Okay, 0 times anything. Any 0 times anything is 0. So this ends up being minus 8x to the 7th over x to the 16th. Did anybody get there? Did anybody get there? Now, how do you deal with exponents when they're like this? How do you deal with exponents when they're like this, guys? Subtract.
Subtract them.
And so what would I get? I would have a minus 8 and then a x to the 9th.
Negative. Oh, yeah, 9.
Now this is where it gets fun.
Why did you write -8?
Oh, because all of these guys got killed. I know that sounds horrible. All these got killed by all of these guys, right? I mean, this is x times x times x 7 times. This is x times x times x 16 times. There's a lot of bloodbath going on as these guys get canceled out, but you're just left with x to the 9th there. But this is the same thing. Take this guy up, and this is the same thing as minus 8x to the, this is the same thing as minus 8x to the negative 9. Like, wow, Dr. Warren, that's a bit of work. That's a bit of work. Miles.
So you would rather have the final answer in a negative exponent than,
You know, Miles, that's a great question. Miles goes, would you rather have, Miles, come on up here, man. Sorry, I won't breathe. Just talk to the camera. They're so tired of seeing and hearing me. You ask that question to the camera.
alright,
Hi,
so,
Miles.
hey, how's it going? So I was wondering if he wanted his answers in a negative exponent form or a positive exponent in the Dunu.
Okay, let's give it up for Miles. He got up here. He was on TV. Miles, it doesn't matter. Miles, it doesn't matter. But let me show you why you probably want to go with the negative exponent. Now, listen to me. How many people think they can take the derivative of x to the 4th? Dr. Warren, you were mumbling. How many people think they can take the derivative of x to the 4th? What's the derivative of x to the 4th? 4x cubed. Listen, just look up here. If you use that same flashcard for this, what would you get? What would you get? If you use this, if you use the k x to the k minus 1, what would you get? What would you get?
Negative 8.
Negative 8. And then what is negative 8 minus 1?
Negative 9.
Holy hell! Holy hell! Look, guys. Oh my gosh. Did we get the exact same thing? Did we get the exact same thing?
Yeah.
So here's the thing. This power rule is sweet. Power rule is really sweet. It doesn't just hold for positive exponents, but it also holds for negative exponents. It also holds for negative exponents. Like, for example, suppose you were trying to find the derivative of x to the minus 101. Suppose you were trying to find the derivative of x raised to the minus 101. Could you guess what that is? Could you guess what that is? What do you think it would be? What do you think we could show that's equal to?
Negative.
Now this is where it gets hard.
Negative 102.
To the negative 102. Negative 102. So this works for positive exponents and it works for negative exponents. So from now on, for example, suppose you were hit by this. Do you guys feel that? Did you feel that? I felt it. Did you? I felt the evil spirit of boredom coming in the room. Did you feel it there? Did you feel the evil spirit of boredom beginning to come in and corrupt your ability to learn? I felt that. Get out, evil spirit of boredom. Get out. I command you. Okay, we're going to get rid of it. We're going to exercise the evil spirit of boredom. Everybody get your hands out. Get your hands out. Get your hands out. Get your hands out. Okay, on 3, we're all going to go, woo! Okay, ready? 1, 2, 3. Woo! Out, evil spirit. Come on, come on. Out, evil spirit. Atone. Out, evil spirit. I guess they can't do that. Okay, good. I think that helped a little bit. I get a sense it's coming back. Okay, I'm not sure we actually killed it. Okay, so like for example, how many people think they could handle this? If you had to take the derivative of a function as nasty as this, if you had to take the derivative of a function as nasty as that, do you think you could take the derivative of that function? Do you think you could find the derivative of that function? Using our flashcards, how many people think they might have a chance of taking the derivative of something like that? Dr. Warren, could you read it for us on the grid? Yeah, 8x to the 6th plus 7x to the 4th plus 3x to the negative 7 plus 5x plus 7. So go ahead, take the derivative of that. You said you thought you could. Take the derivative of that.
Mr. Warren, can you read it one more time?
Yep. Thanks. 8x to the 6th plus 7x to the 4th plus 3x to the negative 7 plus 5x plus 7. I'm hoping on a quest, sorry, Lainey, it's just off on, yeah, it's abuse in here. Okay, it's, on a quest, I'd hope you'd be done. Go to grid view and hold up what you have. You guys just talk to each other here, see if you've got the same thing. Okay, what do you guys have? What do you What'd you get for the first term? 48x to the 5th, and then 28x to the 3rd, and now negative 21x to the negative 8 plus 5 plus 0. Did anybody get that? How many people got that? Excellent. Okay. This next one's tough. So stand up. I know you need it. Stand up. Okay, sit back down. I dread this every time I teach this. Because I know I'm like gonna put most of you to sleep. I know I'm gonna put most of you to sleep. To the point I really fear I could take your wisdom teeth out without you knowing it. I really think maybe I should just sell my lectures as like things you could use before surgery. You know, wait a second. Before you pull those wisdom teeth, let me just listen to Dr. Warren's derivative of the square root function. Just give me a second. Okay, I am now completely comatose. Go after it, go after it. Or as a sleep aid. You can just put my videos on, you know, at night when you're having problems sleeping at 2 a.m. Just put on a Dr. Warren video and just pipe it into your ear. You don't have to look at it, just listen to the and I can see the effect. I mean, look at Kelly. Kelly's there, you know, and Kelly's in bed already. Kelly, you're never gonna make it. You're never gonna make it, Kelly. Okay. Jonathan, you gonna make it?
Oh, yeah.
Okay. Thomas, you gonna make it?
Yeah, I'm gonna make it.
Henry, how about you? You gonna make it?
Yeah, I'm gonna make it.
Okay. This is going to be tricky, so you're gonna have to focus with me. My function is now going to be our dreaded enemy, the square root of x. A foe we've dealt with time and time again. We know the domain, you can't have any negatives. Now, if you were going to explain like the square root of 9 to your little sister, how would you explain that? The square root of 9, how would you explain that? What number times itself is 9? And what number is that? 3. What number times itself is 9? Now, if you talk about the square root of 7, then suddenly it's like, crap. This means what number times itself is 7. So if this is apple, then apple times apple would be, if this is apple, if apple's the square root of 7, then apple times apple is 7. And this is what we need. If f of x is the square root of x, then f of x times f of x is the square root of x times the square root of x, which would be equal to x. Now, once again, we're going on a journey. What did I just say?
Once again,
Going on a journey. We're looking for f prime of x. You're like, crap, Dr. Warren. Well, you've got this. This would imply then that f of x times f of x is equal to x. Now, did I tell you about the time my brother came at me with a soda bottle and tried to cut me up? Did I tell you about that, how he tried to come at and cut me up? Okay, what did Dad do?
You both
both of you.
He spanked both of us. So that's what I'm going to use now. I'm going to use the disciplining. I'm going to discipline this side of this equality with a derivative. I'm allowed to do that provided I'm going to discipline this side of the equality with a derivative. I'm allowed to do that if I spank the other side. Okay? If these two functions are the same, then their derivatives are going to be the same. Then the derivative of f of x times f of x has got to be equal to the derivative of x. But how many people know the derivative of x? How many people know the derivative of the right-hand side? What is the derivative of x, Lainey? 1. So this would be 1. Look at this one. We've got f of x times f of x, the derivative of. Dr. Warren, that was in English. The derivative of f of x times f of x. Do we have a flashcard that could help us with that one? Do we have a flashcard that could help us take the derivative of f of x times f of x?
Yeah.
Which flashcard, guys? Which flashcard? Miles is putting in this one. Julia, if we're looking at this flashcard, we want to use this flashcard to take the derivative of this. Who's playing the role of f of x in that flashcard? Who's playing the role of f of x in that problem? F of x. Who's playing the role of g of x? F of x. So you guys use product rule. Use product rule and write down what you think that derivative is equivalent to. What's the derivative of f times f? You just using that flashcard. For sake of time, I've got to stop you. For sake of time, I've got to stop you. Oh, who do I pick on? Everybody's looking down now. Okay. No, I'm going after, I don't know. Nicholas, you got anything for me, man? Nick, you got anything for me?
I'm sorry.
Okay. Okay, I'll take that as a no. Trey, you have anything for me?
Is it just f prime of x times f of x?
Listen, Trey said it's f prime of x times f of x.
Plus f of x times f prime of x.
That's exactly right, Trey. Let's give it up for Trey. How many, anybody else have that? Did anybody else have that using product rule? I mean, if you just look over here, it's the derivative of f of x times f of x, which is f prime times f, plus f times f prime. Now I know this, please do not yell at me. If you have a pair plus a pair, what do you have? If you have a pair plus a pair, what do you have? Two pairs. Now, if you've got an f prime f plus an f prime f, how many f primes f do you have? Two of them. So this would imply that 2 f of x, f prime x, is equal to 1. Because I've got a pair plus another pair, if I just flip those around.
Would that be the same as 2f prime of x plus 2f of x?
Yep, that'd be the exact same thing.
Professor, can you read that last thing that you wrote down with the arrow pointing to it? Yeah.
Yes, sorry. What's your name again?
Alex.
Alex, thanks Alex. Yeah, it's 2f of x times f prime of x equals 1. 2f of x times f prime of x equals 1. And what's your name here, Alex? Zach. Zach. When will I know I'm done? Remember, we were going on a journey. When would I know I was done with the journey? When they've both been disciplined. I like that. You're ready to be a parent. Oh, yeah. Remember our goal was to find the derivative of f. Do we at least have a derivative of f in play? Is there at least a derivative of f on the field here? Could you isolate f prime, kind of like LeBron James did last night? Could you isolate f prime and get him all by himself? What would you need to do to get f prime alone over here? So he could go drive to the basket. What would you need to do to get f prime all by himself? Divide by 2f. So let's do that. This would imply f prime of x is equal to 1 over 2 times f of x. I was not a math major in college. I know this will be shocking. I was an art major when I was in college. I was an art major, not a math major. So, I could tell by the drawings. I know, you're looking at the pair, and you're like, seriously, Dr. Warren? You were an art major? Okay, but enough. Do we have f prime all by itself? Now this is where the move This is the sneaky move. This is the street magic move. Who was f of x originally? Who was f of x originally? Let's use that. Well, this would imply that f prime of x is equal to 1 over 2 times the square root of x. And there we've got it. There we've got it. The derivative of the square root of x, the derivative of the square root of x is, the derivative of the square root of x is
1 over 2 square root.
Two.
1 over 2 square roots of x. So the derivative of the square root function is 1 over 2 times the square root of x. How many people followed? How many people followed the logic? Is there people that followed? If not, go through the notes again and then see. Now this next thing, I'm getting chill bumps. You guys aren't getting chill bumps, but I get chill bumps at this moment. The square root of x is the same thing as x raised to what power? The square root of x is the same thing as x raised to what power? 1/2. The square root of x is the same thing as x raised to the 1/2. So we just showed that the derivative of the square root of x, which is like x to the 1/2, is equal to 1 over 2 times x to the 1/2. That's what we just showed. Derivative square root of x is 1 over 2 square roots of x. Square root of x is x to the 1/2. But guys, take this up. Take this guy up. Take x to the 1/2 up, and he becomes x to the... Take x to the 1/2 up, and he becomes x to the... Takes x to the 1/2 up, and he becomes x to the... negative 1/2. So this is the same thing as 1 over 2, and I guess I'll just take this up like this, x to the negative 1/2. Which is the same thing as 1/2 times x to the negative 1/2. And like that's one, I'm not getting it. I'm not getting it. Guys, look. Look. What's the derivative of x to the 1/2? What's the derivative of x to the 1/2? What's the derivative of x to the 1/2?
1/2.
Half x to the negative 1/2. What if you used power rule? What if you used power rule? Let's just see. What would I do with the 1/2? What would I do with the 1/2? Dump it down. What would you do with that little 1/2? Subtract 1. What is 1/2 minus 1? Negative 1/2. Power rule doesn't just work for positive numbers and negative numbers. It also works for fractions. It also works for fractions. I mean, this is pretty sweet. Like, for example, let's end class with this. Okay. Now, guys, I realize you do not do well at adding fractions and subtracting fractions. But like, for example, if you had x to the 2/3, and you want to take the derivative of it, guess what we can show? Using similar kinds of arguments to this, guess what we can show the derivative of x to the 2/3 is? Guess what we can show it is? 2/3. Now this is where it gets hard. 2/3 minus 1. That should not be the hard part. 2/3 minus 1 is negative 1/3. And that's what it is. That's what it is. In fact, power rule works for any exponent whatsoever. Power rule works for any exponent whatsoever. How many people like power rule? How many people like power rule? How many people like power rule? Yeah, it's a pretty sweet rule. It's a pretty sweet rule. So we're gonna finish with this rule. We've just upped our power rule. Sorry, does anybody else play video games? I shouldn't be a 60-year-old who plays video games, but like, does anybody else play video games? And you go around and get powers. Can you go around and get powers? I mean, you go around and you up your powers as you play. We just up this power. We just up this dude's power a lot. What does this symbol mean? What does that symbol mean? What does that mean? What does that
All
mean?
real numbers.
All real numbers. This works k, x to the k minus 1, for any k. That's a real number. It doesn't need to be a whole number. It doesn't have to be a positive number. It doesn't have to be a negative number. It doesn't have to be a fraction. It works for x to the freaking pi. What's the derivative of x to the pi? Pi x to the pi minus 1. Which frees us up a lot. Okay, you're gonna have a WebAssign due Friday. Okay, guys, wash your hands, stay well. I cannot lose you again. Bye, guys.
Thank you, Dr. Warren.
Thank you, guys. Well, guys, thanks for coming to class. You have no idea how nice it is to teach students. I mean, as much as the grade kind of like gets it, it's just not quite the same.
Thank you.
Thanks, Shay.
Have a good rest of your day.
Zach, no.
Thank you.
Zach, right?
Oh, yeah, you got it right. Those that.
Oh, Zach, okay. Max, no. Jonathan. Chase.
It starts with a C though.
Clay.
Starts with a CH.
It's not Chase.
No,
Chad.
no, there's no way.
Okay, now I feel like I'm on the Wheel of Fortune. What's
Christopher.
Christopher. Okay, Christopher. I'm gonna get it. And Trey.
Yes,
Now, Trey, did you send me an email?
I did.
Okay. It'll be a lot easier. It's a lot easier than going back. Yes, Trey, I do want to get together
Right.
and talk.
Perfect.
Sadly, I can't. My
No,
office
yeah,
hours are
of
shot
course.
now. But I think by getting flashcards and then coming to office hours, you know, where we can work one-on-one, I think that will help a lot.
I just really wanted to make sure from where I'm standing right now, like I can sort of kind of come back.
When I was a student, I would go talk to my professors, and they would tell me, oh yeah, I think everything's gonna be great, and then I would get a D or an F, you know, I mean, it was just constant. So I try to be really honest with my students, you know, and until I see that second quest and see how you did on it,
Mhm.
I won't know exactly what to answer that, but I do think that the more time we spend together,
Yeah.
and I promise, I'm ADD, I promise not to keep you long. Usually 5 minutes, 10 minutes is about all the brain before the water starts pouring over the cup. I'll keep talking, and 5-10 minutes regularly is much better than like trying to get 3 hours in.
Mhm.
You know, so also the SMLC, the Science and Math Learning Center, has Zoom hours also, where you can set up with a personal tutor
Okay.
and get Zoom help. And if you could, I don't know if Jenna Gunther is tutoring, she's amazing. And so setting up some synchronous hours, because it's free. I mean, you might as well use it, it's
Right.
free. And you can get one-on-one tutoring with a peer that is usually really good for this
Okay,
class.
yeah, definitely after grading and all the next class, just we'll get together or something.
That would be awesome.
Talk
That would be awesome.
specifics and I guess just see where we are.
Because I want all my students to be successful. I want to get all
Yeah,
of
it
them.
was just getting out of hand and I was like, I might as well just email him and I was like,
Trey,
I wanna
thank
get
you.
back on track.
No,
No, I
thank you.
appreciate it.
No,
Thank
it
you so
means
much.
more than you know. It means more than you
Thank
know.
you, thank you.